This is an overview of my aquaponics project that I've completed this summer. My name is Jeff, and I'm a UC Davis student studying mechanical engineering. And this project is the next iteration of this stock pond project that I've been working on for a few years now. So I designed the system as a complete cycle, starting from the main tank, where I have the solids lifting overflow, also abbreviated as the slow. So as water is pumped into the tank, water must leave the tank from the slow, which would push debris up the standpipe and sending it down these two 90-degree sweeping bends and through a ball valve. From there, the solids are pumped into a radial flow settler and up the stilling wall, which slows down the solids and allows them to settle at the bottom. Near the top of the radial flow settler is an outlet pipe with a 90-degree elbow that acts as a skimmer. This is the first stage of mechanical filtration that removes large solids. At the bottom of the radial flow settler, I have a spigot that allows me to drain the solids out and water my garden. From the radial flow settler, the water enters the quote-unquote sump tank, where water is poured on top of a DIY bucket filter that I made. In the bucket, there are a few layers of sponge, lava rock, another few layers of sponge, filter floss, and a final layer of sponge. The top layer of sponge traps floating debris, and the filter floss catches anything that's remaining. This is the second stage of mechanical filtration. The bottom layers of sponge and lava rock to act as biological filtration, as they provide the necessary surface area for nitrifying bacteria to break down the ammonia into nutrients for the plants I have in the grow bed. I have this 15-watt pump running at around 300 gallons per hour up this clear vinyl tubing and up into the grow bed, where I currently have some floating water lettuce and hyacinth. I can also grow some herbs in here as well. The water re-enters the main tank through this pipe, which has a fitting I created in SolidWorks and 3D printed. The fitting has a removable piece of sponge, which slows down the water to reduce noise and prevents dead plant matter from entering the system. Like that, the system runs in a loop. This system is a complete upgrade from the previous setup, which worked fine, but I had several main problems with. First, maintenance on the old pond was a large task that needed to be completed frequently. I used this box filter rated for 160 gallons per hour, running at 19 watts. My main issue with it was that the filter box would get clogged easily with waste and plant matter, making maintenance a weekly occurrence. Over time, waste and plant matter would get stuck in the impeller as well. I wanted to create a more robust filtration system that required less maintenance, especially because I'm going off to college and I wanted to make it easier for my family. In the new system, maintenance is a lot easier, as the water level in the pond is constant and all I need to do is to add water into the sump tank. When the water level gets low, I can just add water with the hose, dechlorinate the water, and let the system run up again. The pump is also located away from the main tank, preventing large debris from becoming stuck in the filter. Additionally, I can access and rinse off filters a lot easier. Second, the efficiency and noise of the system was something I wanted to improve on. In the old setup, I was using a 19-watt pump and a 2-watt air pump. With the larger volume of water in the system, I wanted to increase the volume of water pumped throughout the system and increase the dissolved oxygen levels within the water. In the aquaponics setup, I'm using a 15-watt pump that moves a larger volume of water and a 4-watt air pump moving air at around 7 liters per minute, which improved from the previous system. Overall, I've lowered the energy cost of running the system and made it more efficient. The new setup runs a lot quieter as I've worked to reduce vibrations created from the air stoat and pump. Third, location. The previous setup was located in the back of the house, which reduced the amount of sunlight exposure the pond received. This contributed to lower average water temperatures. Although I created a lid with a twin-wall polycarbonate panel to insulate the pond, my solution didn't feel adequate enough. For this project, I placed the pond in the front of the house where the pond receives full sun from the morning to about 2 at noon. This increases the average water temperature, and I expect to see this continue during the fall and winter months. Fourth, better protection from predators. I've had an issue with raccoons eating my fish, and even though I created a lid, the measures I took were not enough. For this project, I bent 3/4 inch PVC into halves of a lid and held them together with these aluminum hinges. I've placed netting on the lid, which allows me to feed the fish without opening the lid. I've also designed these pegs that I 3D printed, which prevent the lid from being opened unless the overhang is rotated. I know this project isn't strictly a mechanical engineering project, but I really enjoyed applying problem solving and design-oriented thinking into this project. I think I basically addressed all the issues I had with the previous version of the project, so I'm really happy with that. And as I've been working on this project for a few years, I've continually upgraded it over time. So the next upgrade I have for this is integrating a temperature and TDS sensor with an ESP32, and that'll allow me to basically collect and view live data on the pond while I'm away at school. And since I'm leaving home in a few days to go to school, I probably won't be able to get that done for here, but I'll finish that at some point and I'll film that too. So thank you for watching my overview of my stock pond aquaponics project. I probably have 10 hours of footage of me just working on this, so I'll probably make some videos maybe about the design process and some of the manufacturing that I did, and I'll post those as videos. So if you're interested, I guess you can stay tuned.